Are you ready to learn the truth about how people cross the oceans blindly? What I am about to reveal will turn your understanding of ancient navigation upside down. For many years, scientists have grappled with the mystery of how northern navigators maintained perfect orientation in the vast waters. These rugged travelers ventured thousands of kilometers from their home shores without a single instrument. Their navigation methods seemed mystical until researchers uncovered surprising facts. Watch the video to the end, and you'll learn how an ordinary clear crystal replaced a modern satellite tracking system for an entire fleet. For decades, Victorian scientists considered the northern seafarers to be nothing more than lucky wanderers. Historians sifted through dusty manuscripts in search of answers about ancient routes. They stumbled upon strange references to magical sunstones in ancient sagas. At first, these records were dismissed as beautiful myths or the fabrications of ancient storytellers. What they found in the old archives astonished the entire scientific world of the 19th century. A thorough analysis of the texts forced researchers to change their minds. Scientists realized that these were real physical objects with unique properties. The texts described transparent minerals capable of indicating the position of the sun even in cloudy weather. Such stones do indeed exist in nature and possess a special light refracting effect. Iceland's spar became the leading candidate for this mysterious navigational tool. The crystal changed color when held up to a light source hidden behind clouds. Sailors would hold this mineral up to the sky during thick northern fogs. They would slowly rotate the stone before their eyes, closely observing the change in its hue. At a certain moment, the crystal's facets would begin to glow with a pale yellow or bluish light. This glow precisely indicated the direction of the sun, hidden behind a thick veil. In this way, navigators gained a reliable guide in completely impenetrable weather. The process required immense experience and the utmost concentration. One had to take into account the time of day and the approximate height of the sun above the horizon. A miscalculation could lead the ship hundreds of miles off course. Therefore, the keepers of the stones were held in the highest regard among the crew. They passed down their skills from generation to generation in the strictest secrecy. This crystal was the most valuable object on board any wooden drakkar. Victorian researchers conducted a series of practical experiments with Icelandic spar. They set out to sea in cloudy weather and attempted to determine their course without a compass. The results of these tests fully confirmed the ancient texts with incredible accuracy. The stone unerringly pointed the way, even through the thickest cloud cover. Scientists were amazed by the level of knowledge possessed by people who lived 1,000 years ago. Finds in sunken ships confirmed the Victorian scientists' theories. Archaeologists discovered pieces of Iceland's spar among the navigational tools of ancient navigators. One such crystal lay next to wooden measuring instruments. This became irrefutable proof of the mineral's practical use. The scientific community finally recognized the genius of this primitive navigation system. The stone ceased to be a myth and took its place in the history of discoveries. For many years, this secret remained hidden from the rest of humanity. European sailors continued to rely on clear skies and the visibility of the stars. The advent of the magnetic compass later leveled the playing field for all conquerors of the seas. But it was transparent spar that made the earliest ocean crossings possible. This story proves that ingenious solutions often lie right on the surface. Today, these crystals are housed in the world's largest historical museums. Visitors can see the tools of ancient explorers with their own eyes. Each such discovery tells an amazing story of overcoming natural obstacles. Intelligence and observation replaced complex electronic mechanisms for people. It would be very interesting to hear your perspective on this. What do you think about the use of natural stones in navigation? Write about it in the comments and be sure to subscribe to our channel. I'm going to reveal the best-kept secret of ancient navigators right now. Seafarers knew how to read the ocean's surface like an open book with clear text. Waves carry a vast amount of information about distant objects. The wind creates a specific rhythm and pattern of movement on the water's surface. This pattern changes when it encounters obstacles such as islands or continents. A trained eye can spot these changes from many tens of kilometers away. Long ocean waves are called swells and travel over vast distances. They maintain their direction even in the complete absence of a favorable wind. Navigators memorize the direction of the main swell at the very beginning of their journey. They use this rhythmic dance of the water as a reliable guide. The ship moved at a certain angle to these constant water waves. Approaching land altered the familiar pattern on the water's surface. Waves reflected from the shore met the main ocean swell. As a result, a distinctive crisscrossing grid of ripples formed on the water. Sailors would peer intently at the water, searching for these intersecting lines. The appearance of such a grid served as a sure sign of the long-awaited land's proximity. The shape of the grid cells suggested the approximate distance to the hidden shore. The speed of the waves also provided important clues to attentive observers. In shallow water, the massive bodies of water begin to slow their course. The distance between the crests shortens, and their height increases noticeably. The ship began to rock more violently on the shorter, steeper, watery hills. This signaled the approach to the continental shelf or the proximity of reefs. The sound of the surf carried across the water's surface for many miles around. In calm weather, the rumble of waves crashing against the rocks served as an acoustic beacon. Different types of coastlines produced completely different sounds. Steep cliffs echoed the impact of the water with a deep, rumbling roar. Gentle, sandy beaches rustled softly and evenly like the breath of a giant. The ability to read the water allowed one to find not only land, but also currents. The boundaries of ocean rivers are often marked by small whirlpools and foam. The water in currents can differ in temperature and density. Getting into such a current significantly sped up the journey to the intended destination. Sailors deliberately sought out these waterways to conserve energy. Skillful use of currents made their voyages incredibly fast and efficient. This method required a constant human presence on deck. They could not let their attention wander for even a minute, lest they lose the necessary rhythm. Navigators stood watch for hours on end, staring intently at the endless play of the waves. Their eyes stung from the salt water and the blinding glare of the sun's reflection. But it was precisely this vigilance that ensured the safety of the entire crew of the wooden vessel. Observing the waves remained the foundation of navigation until the advent of precise instruments. Even today, experienced sailors can tell a great deal from the patterns on the water. This is basic knowledge of nature that doesn't depend on batteries or satellites. Do you agree that nature gives clues to those who know how to look for them? In the next chapter, you'll learn how a simple wooden board replaced the most complex astronomical instruments. What large companies hide often turns out to be long-forgotten technology from our ancestors. In Greenland, archaeologists unearthed a strange wooden object with notches along the edges. It was a fragment of a small disc carved from a single piece of sturdy wood. Scientists puzzled for a long time over the purpose of this seemingly primitive little object. It turned out that they were looking at a unique solar compass used by ancient seafarers. This piece of wood helped them cross the Atlantic without magnetic needles or dials. The disc's design was ingenious in its absolute simplicity and practicality. In the center of the wooden circle was a hole for a vertical rod. Along the edges of the disc, craftsmen carved numerous notches of varying depths and shapes. These notches corresponded to specific cardinal directions and important navigational landmarks. The disc was placed strictly horizontally on the deck of a wooden ship or in a special bowl of water. The shadow from the central peg fell on the edges of the disc, indicating the exact time and direction. Using the compass required knowledge of the sun's path across the sky in different seasons. The sun changes its altitude above the horizon depending on the time of year. Navigators would pre-draw curved lines on the disc, showing the movement of the sun's shadow. These lines served as a reliable route for a specific latitude during long voyages. The sailor only had to ensure that the tip of the shadow always moved along the drawn curve. This guaranteed that the ship was sailing exactly west or east. Creating such an instrument required serious astronomical observations on land. The craftsman had to record the length and direction of the shadow at different times for months. Each curve on the disc was the result of painstaking labor and mathematical calculations. The wooden compass was calibrated for a specific route and a specific time of year. Using someone else's disc, or one that was incorrectly marked, led to fatal errors in navigation. The discovery of the Unartok disc became a true sensation in historical science. It dispelled the myth that ancient sailors sailed exclusively by guesswork. They possessed a complex system of measuring instruments made from readily available materials. Wood was easy to work with and did not sink if accidentally dropped overboard. These instruments were guarded like the apple of one's eye and hidden in the captain's chests. Modern reenactors have recreated this disc and tested it in actual sailing. The results of the experiment exceeded even the most optimistic expectations of skeptics. The wooden compass allowed them to chart a course with an error of only a few degrees. This is an incredible result for an object carved with an ordinary knife. The practical test definitively proved the effectiveness of the ancient navigation system. Science has recognized the outstanding contributions of the navigators of the past to global seafaring. This artifact tells a story of the power of human intelligence. The lack of metal and magnets did not prevent them from conquering the oceans. People used geometric principles and keen observation instead of complex technologies. A sharp mind served as a substitute for electricity, radar, and satellite communications. Their legacy continues to amaze researchers with its ingenious simplicity. Today, a replica of this disc holds a place of honor in maritime history museums. It serves as a reminder that technology doesn't always solve everything. A deep understanding of nature and the laws of physics can work true miracles. Ancient instruments still hold many unsolved mysteries. If you enjoy learning about such unique inventions, be sure to like this video. Your support helps us find new and exciting facts. Are you ready for the shocking truth about coastal navigation in ancient times? Crossing the ocean always began and ended with the ability to navigate near the coast. The coastline was a continuous chain of visual cues for the experienced eye. Every mountain, distinctive cliff, or deep fjord had its own name and significance. These landmarks were memorized and passed down to young sailors as verbal instructions. A mistake in identifying a single cape could lead a wooden ship onto deadly rocks. The shape of the coastline played a key role in determining their location. Sailors memorized the silhouettes of mountains against the bright sky with striking accuracy. They knew what every hill looked like from different sides and at different viewing angles. Tall, snow-capped peaks served as lighthouses, visible for tens of kilometers. Navigators steered the ships so as to keep certain peaks in a straight line. This method of sighting allowed them to safely pass through narrow straits and avoid shoals. The vegetation on the shores also served as an important marker for determining latitude. The northern shores were covered with dense coniferous forests or rugged moss. As they moved south, the nature of the trees and shrubs changed noticeably. An experienced sailor could determine his approximate location by the color of the autumn foliage on the mountain slopes. The absence of forests indicated the approach to barren, rocky islands. Green valleys promised fresh water and the possibility of a safe anchorage. Smoke from the locals' campfires helped them find safe harbors. Settlements were often located in bays and river mouths sheltered from the wind. Spotting a thin column of smoke, the navigator steered the ship toward the inhabited shore. It was a sign that shelter and food could be found there. The smoke was visible from much farther away than the low wooden structures themselves. Shallow waters and water depth were easily discerned by the nature of the coastal seaweed. Huge clusters of brown plants indicated the presence of rocks hidden beneath the water. Sailors kept a close watch for floating patches of seaweed, steering clear of them. The color of the sand in shallow water also warned of potential danger. Bright white patches on the seabed signaled a sharp drop in depth and the risk of running aground. Dark depressions indicated a safe and deep channel for the ship to pass through. The sound of coastal waterfalls served as an excellent auditory guide in thick fog. The loud roar of falling water carried far across the surface of the quiet bays. Sailors knew the locations of the largest waterfalls along their traditional routes. Upon hearing the familiar rumble, they could adjust their course without seeing the shore itself. The sound echoed off the sheer cliffs, helping to determine the distance to the rock face. The shape of the clouds above the shore often mirrored the contours of the land itself. Moist air rose over the mountains and condensed into fluffy white caps. These stationary masses of vapor hung over the islands even in windy weather. When sailors spotted such a stationary cloud out at sea, they knew that land lay hidden beneath it. This allowed them to set a course for the island long before it appeared above the horizon. Nature itself set up giant signposts in the sky for attentive travelers. The reflection of light from glaciers and snowcaps provided another clue. On clear days, the white ice sparkled in the sun with dazzling flashes. This glow was visible from a vast distance, beyond the reach of ordinary sight. In cloudy weather, the glaciers cast a bright haze onto the lower edge of the clouds. This phenomenon helped them unerringly locate the icy coasts of the northern islands. The outlines of the shores were sketched not on paper, but in the navigators' memories. They mentally created three-dimensional maps of the coastlines, marking all hazards. This mental navigation was more reliable than any parchment scrolls. A sailor could instantly recall the necessary section of the route in a critical situation. Memorizing visual landmarks was a key part of training future captains. Their knowledge was tested through constant quizzes and questions from senior crewmates. The ability to read the coastline saved countless lives in wooden fleets. Every rock and shoal was part of the vast navigational library of antiquity. This knowledge allowed people to master the harshest and most inhospitable shores on the planet. Visual landmarks remained a sailor's primary tool for millennia. How else would you memorize hundreds of kilometers of monotonous rocks without a single map? In the next chapter, you'll learn how invisible air currents dictated their own rules to seafarers. Understanding wind behavior was a critically important skill for steering a sailing vessel. The northern seas are famous for their unpredictability and sudden weather changes. Ancient navigators didn't just catch a favorable wind, they sensed its onset. They closely studied the seasonal shifts in the direction of the major air masses. Each season was characterized by its own prevailing winds, blowing with a certain strength. Planning long-distance voyages was strictly tied to these climatic cycles. The sensation of the wind on the face served as the primary tool for determining its direction. The navigator would turn his head until the air pressure on both cheeks became equal. This allowed him to determine the direction of the wind with an accuracy of a few degrees. The temperature and humidity of the incoming air provided information about its origin. A cold, dry wind always signaled the arrival of air masses from the icy northern expanses. A warm, humid breeze indicated the approach of storm fronts from the south. The shape of the sail served as an excellent indicator of the slightest changes in air currents. A square sail reacted to a shift in the wind with a slight tremor at the edges. The helmsman constantly monitored the tension of the sail and the ropes, adjusting the course. The sound of the fabric flapping in the wind warned of a loss of traction or a change in wind direction. Steering the vessel required constant interaction between man, wood, and coarse woolen fabric. Clouds were the main harbingers of impending changes in wind strength. Feathery clouds racing high in the sky warned of an approaching storm. Heavy, dark clouds on the horizon signaled an impending squall with rain. Reading the cloudy sky was a mandatory skill for every crew member. The captain made decisions about changing sails or seeking shelter based on these observations. A mistake in assessing the weather could cost the entire ship and its valuable cargo. Tornadoes and waterspouts posed a tremendous danger to fragile ships. Upon noticing the formation of a characteristic funnel, the crew immediately changed course. Navigators knew that these phenomena often occurred at the boundaries of cold and warm fronts. They tried to avoid areas of the sea with unstable air temperatures. The ability to anticipate the onset of extreme weather conditions was key to survival. The behavior of smoke from the ship's stove helped determine wind strength. Food was prepared in small boxes filled with sand right on the open deck. If the smoke rose vertically, it meant the ship's speed matched the speed of the tailwind exactly. Smoke creeping across the deck indicated a strong crosswind or headwind. This simple visual indicator allowed for fine-tuning the sail's position. Long periods of complete calm were a terrible ordeal for the crews. Ships could drift for weeks in stagnant water under a scorching or freezing sun. At such times, all hope rested solely on the physical strength of the rowers. Long, heavy oars were lowered into the water, slowly pushing the heavy hull forward. It was exhausting labor that depleted the ship's supplies of food and fresh water. Emerging from a calm was always a huge celebration for the exhausted crew. Understanding the winds transformed the elements from a formidable enemy into a reliable ally. Ancient seafarers did not fight nature. They learned to harness its power for their own benefit. This required immense patience, keen observation, and respect for the ocean. Invisible air currents became the rails along which trade and exploration fleets moved. Man and the elements merged into a single mechanism conquering the boundless expanse of water. The wind became the main engine of progress and geographical discovery in that harsh era. Guess what happened next in the development of ancient navigation technologies? After mastering the sundials, navigators learned to use ordinary shadows for highly accurate calculations. The ship's mast became not just a support for the sail, but also a giant sundial. The length and direction of the mast's shadow changed throughout the daylight hours. At noon, this shadow always pointed strictly north, setting the main direction of travel. Navigators marked the deck with special notches to track these changes. At sunrise and sunset, the shadows became as long as possible and pointed west and east. These moments of the day were the most important points for verifying and adjusting the chosen course. The helmsman closely watched how the first rays of the sun fell on the deck. If the shadow from the mast lay parallel to the deck planks, it meant the ship was heading straight east. Constant monitoring of the shadow's position ensured minimal deviations from the planned route. In winter, the sun rose low above the horizon, casting long shadows throughout the day. This greatly complicated navigation, as the difference between the morning and midday shadows was minimal. In summer, on the other hand, the sun was high in the sky and the shadows were short and distinct. Sailors had to account for these seasonal changes in their mathematical calculations. An error in determining the season led to catastrophic errors in setting the course. Navigating by shadows was impossible at night and on cloudy days. During such periods, navigators relied on their other senses and auxiliary methods of orientation. Waiting for the sun became a real test of nerves for the entire ship's crew. The appearance of the first ray through the clouds was met with joyful shouts and an immediate course correction. A patch of light on the deck was the best friend of people lost at sea. Using the shadow required a perfectly straight and strictly vertical pole. Wooden masts often warped from dampness and the constant tension of the rigging. Therefore, navigators preferred to use small, carefully calibrated reference rods. These rods were made of hardwood or even carved bone. They were stored in special cases that protected them from moisture and physical damage. A reference rod was as valuable as a clear sun crystal. Training in the use of shadows began on land from early childhood. Future navigators spent years observing the sun's movement on special platforms near their homes. They stuck sticks into the ground and marked the edge of the shadow with pebbles throughout the day. This prolonged practice fostered a deep, intuitive understanding of the laws of celestial mechanics. People learned to sense time and direction without complex mechanisms or dials. A true master could determine a course with just a quick glance at the shadow of his own hand. The shadow method complemented the system of observing ocean swells in watercolor. This comprehensive approach minimized the risk of fatal error in the boundless expanse of water. If one method failed due to the weather, there were always backup options. This redundancy in the navigation system became the key to survival in the harsh northern latitudes. It was thanks to this that tiny wooden vessels successfully crossed the Atlantic time and time again. Sunlight and a simple shadow became the first reliable instruments in human history. They allowed people to venture beyond the sight of their native shores and usher in the age of discovery. This primitive yet incredibly accurate system endured for hundreds of long and difficult years. Could you chart a ship's course using only a stick and its shadow? In the next chapter, you'll learn how the night sky became a giant map for sailors. The night sky served as an inexhaustible source of navigational information for ancient seafarers. On clear nights, the dome of thousands of shining points turned into the most accurate and detailed map. The North Star, fixed in its position, has always been the primary guide in the Northern Hemisphere. It consistently points north, barely shifting its position above the horizon. Finding this bright star was enough to confidently set a course in any direction. Other constellations were also used to chart courses in various directions. The appearance of certain stars above the horizon signaled the arrival of a specific season or month. Sailors knew the times of sunrise and sunset for dozens of the brightest night stars. They drew imaginary lines between the ship's masts and the rising stars. By keeping a star in the correct alignment, the helmsman maintained a perfectly straight course in complete darkness. This method was called the star track and was actively used when crossing open stretches of sea. The Milky Way was a vast, luminous band spanning the entire sky. Its position relative to the cardinal directions changed in a predictable and regular manner. On clear nights, this stellar river provided an excellent additional reference point for verifying direction. Navigators perceived the night sky as a single living mechanism with clear and understandable rules. They memorized star charts, turning their memory into a vast astronomical atlas. Stargazing depended heavily on weather conditions and the phases of the moon. A full, bright moon illuminated the sky, obscuring faint stars that were crucial for navigation. Thick cloud cover made celestial navigation an absolutely impossible task for weeks on end. In such cases, the crew had no choice but to rely solely on the direction of the swell and the tailwind. The transition from clear skies to overcast conditions required a quick change in methods to maintain the correct course. Sailors had to be flexible in their thinking and adapt instantly to new conditions. Ancient legends and myths were closely intertwined with practical astronomy. The names of constellations often reflected important elements of the daily life and beliefs of northern peoples. These stories helped young sailors more easily memorize the positions of the celestial bodies. Mythology served as a mnemonic tool for storing vast amounts of navigational data. Tales of gods and heroes became strict instructions for survival on the open ocean. A mistake in identifying a star could have the most tragic consequences for the entire crew. Stars of similar brightness could lead an inexperienced navigator astray from the correct course. Therefore, the right to make navigational decisions was entrusted only to the oldest and wisest sailors. Their eyes, accustomed to the darkness, could distinguish the subtlest nuances of color and the flickering of distant suns. They spent sleepless nights on the wind-swept deck, guarding the peace of the sleeping crew. Astronomical navigation left no physical traces in the form of instruments or charts. All knowledge was stored exclusively in the human mind and passed down orally. This made the system vulnerable, as the death of an experienced navigator would jeopardize the entire voyage. Captains always tried to have several people on board who were trained to read the night sky. Redundancy ensured the safety of the wooden vessel on long and dangerous expeditions. When we look up at the starry sky, we see the same picture that seafarers saw 1,000 years ago. These eternal lights continue to shine, reminding us of the great voyages of the past. Studying the starry sky was humanity's first step toward understanding the structure of the universe. Practical necessity gave rise to the science that later took humans into outer space. The sky has always been and remains the largest and most accessible guidebook for travelers. The daytime sky provided no less information than the nighttime constellations. The shape, color, and speed of the clouds served as vital indicators to the experienced eye. Sailors knew how to distinguish ordinary weather clouds from those that formed over land masses. Land absorbs and releases heat in a completely different way than the endless water surface. This temperature difference creates updrafts of air over large islands and continents. As a result, characteristic stationary clusters of dense vapor form high in the sky. These stationary clouds resembled tall white towers hovering above the horizon. Even in strong winds, they maintained their position, constantly replenishing themselves with warm air from below. Upon spotting such a tower, the navigator knew for certain that the long-awaited land lay beneath it. The cloud served as a giant lighthouse, visible from dozens of nautical miles away. This allowed the course to be adjusted long before the rocky shores came into view due to the curvature of the planet. The color of the cloud's lower edge also carried critically important information about the surface. The dark water of the open ocean absorbs light, so the clouds above it have a gray underside. The light-colored sand of shallow waters or vast ice fields reflect the sun's rays upward. As a result, the underside of the cloud takes on a characteristic light or greenish glow. This phenomenon was actively used when searching for passages through the ice off the coast of Greenland. Upon noticing a light haze, the captain would steer the ship toward it in the hope of finding solid ground. The rate of change in cloud cover warned of sudden weather shifts. The rapid appearance of high cirrus clouds served as a sure sign of an approaching storm. The crew gained precious time to lower the sails and prepare the ship for the onslaught of the elements. The slow spreading of stratus clouds signaled the onset of a prolonged period of drizzling rain and calm. The ability to read these atmospheric signs was key to survival in harsh conditions. A mistake in the forecast could cost the ship a broken mast or even sinking. The shape of the clouds depended on the terrain hidden beneath them. High mountains created wavy, ridge-like cloud formations on the leeward side. Flat islands gave rise to uniform, dome-shaped clusters of moist air. A navigator could not only find land, but also determine its approximate topography based on these features. This helped choose the right approach to an unfamiliar shore and find shelter. Nature created in the sky an exact holographic copy of what lay far below. In tropical latitudes, cumulus clouds gathered over the atolls in the afternoon. The heated sand created powerful updrafts, visible from afar against the backdrop of a clear sky. In the northern seas, this effect was less pronounced, but an experienced eye could discern the difference. Sailors would stare at the horizon for hours, filtering out ordinary clouds from stationary landmarks. This work required the utmost concentration and immense visual strain. Fog was the main enemy of visual navigation and a source of constant danger. A thick white veil hid the sun, the stars, and the towering clouds over land. At such moments, the crew relied on their hearing, trying to catch the sound of the surf or the creaking of trees. Low, layered clouds merging into fog often signaled a collision between warm and cold currents. Knowing the location of such zones helped navigators determine their approximate position. The color of the sky at sunset and sunrise provided a long-term weather forecast for the coming day. A crimson sunset often foreshadowed strong winds and rough seas the next day. A clear, golden morning promised fair weather and favorable conditions for a long voyage. These signs had accumulated over centuries and were passed down by word of mouth through generations of sailors. They evolved into a unique folkloric compendium of ancient meteorological laws. Reading the sky was an art inaccessible to ordinary land dwellers. Sailors perceived the airy ocean as an extension of the watery ocean. Processes in the atmosphere directly dictated the rules of survival for wooden ships on the water. Attention to detail and a deep understanding of the laws of physics served as a substitute for barometers. Their ability to analyze disparate natural phenomena coalesced into a single, reliable system. Clouds were free and always available aids to the ancient conquerors of the seas. They didn't break, sink, or require special care, unlike fragile instruments. All one needed was the ability to correctly decipher the message that nature wrote in the heavens. This skill allowed people to feel confident far from civilization and familiar landmarks. Cloud navigation became a striking example of the harmonious interaction between humans and the surrounding world. The ocean's surface is never completely still, even in the dead of calm. Huge masses of water are constantly moving, forming global ocean rivers. These currents possess tremendous power and are capable of carrying objects thousands of kilometers. Ancient seafarers knew of the existence of these waterways and made active use of them. Catching a favorable current significantly reduced travel time and conserved the rowers' strength. Moving against the current, on the other hand, exhausted the crew and led to a dangerous depletion of supplies. Detecting the presence of a current in the open sea was an incredibly difficult task. The water around a ship appears uniform, and it is very difficult to visually detect movement. Navigators paid attention to changes in water color and temperature over the ship's side. The boundaries of major currents are often marked by accumulations of foam, small debris, and floating algae. A change in water temperature could be felt simply by dipping a hand over the side. A sudden warming of the water often signaled into the powerful Gulf Stream. A piece of driftwood floating on the waves served as an excellent indicator of the direction of ocean rivers. Tree trunks, uprooted on distant continents, traveled across the seas for years. Sailors carefully examined every piece of wood they caught, determining its species. Siberian larch or Canadian pine revealed exactly where the water had come from. A cluster of driftwood often indicated the proximity of a shore where the currents were washing up their cargo. Wood on treeless islands was worth its weight in gold and was used to build houses. The ship's speed was measured using a primitive but fairly accurate visual method. A splinter was thrown into the water from the bow, and the time it took for it to reach the stern was counted. Knowing the exact length of the ship, the navigator could calculate the approximate speed. If the speed relative to the water was high and the coastal landmarks were moving slowly, the ship was sailing against the current. This method allowed for timely course corrections and the search for detours. Mental calculations were performed continuously throughout the long watch. Ocean whirlpools posed a serious threat to small wooden vessels. They formed where powerful tidal currents met narrow, rocky straits. The famous maelstrom off the coast of Norway struck terror into the hearts of generations of northern sailors. Navigators memorized the tide tables to pass through dangerous stretches during periods of calm water. A mistake in timing calculations led to loss of control and the ship's destruction in a churning vortex. Understanding the rhythms of the ocean's breath was a matter of life and death for the entire crew. Warm currents not only sped up the journey but also had a significant impact on the local climate. They brought warm air, freeing the coastal lands from the harsh, icy grip of winter. Cold currents, on the other hand, cooled the air, causing thick fog and poor visibility. Sailors used this knowledge to predict the weather along their route. Entering a cold current zone required increased vigilance due to the risk of encountering floating ice. Organic debris also served as a kind of compass. Huge clusters of brown algae, torn from the seabed by storms, drifted at the mercy of the currents. Upon spotting such floating meadows, navigators could determine the direction of the surface currents. Sometimes these clusters were so dense that they significantly slowed the ship's progress. The helmsman had to maneuver, selecting clear stretches of water for the wooden keel to pass through. The know-how of navigating currents was passed down through detailed verbal descriptions of routes. Veteran sailors told the young ones where the water would help and where it would begin to resist. These invisible paths were etched onto the mental map of every professional navigator. They knew at what angle to enter the current to achieve maximum acceleration. The art of using currents was like riding on the back of a huge and unruly beast. It was impossible to tame it, but one could learn to harness its power. Currents helped lead to accidental geographical discoveries. A ship that had lost its course due to a storm would be swept up by a powerful current and carried off into the unknown. It was precisely in this way, at the mercy of the elements, that many remote islands of the North Atlantic were discovered. Once on new land, the surviving sailors carefully memorized the way back. They analyzed the winds and currents to return home and tell of their discovery. A mistake turned into a triumph thanks to the observers' keen eyes and analytical minds. Today, satellites draw detailed maps of ocean currents in real time. We know exactly the temperature, speed, and direction of every waterway on the planet. But 1,000 years ago, all this data was obtained at the cost of incredible effort and risk. Intuition, combined with hard-won empirical experience, served as a substitute for electronics. Ocean currents served as reliable guides for those who knew how to read them correctly. In the absence of paper maps and printed pilot books, the spoken word remained the primary medium of information. Navigational knowledge was recorded in the form of long, rhythmic verses and detailed narratives. Rhythm and rhyme helped the human brain better memorize vast amounts of precise data. These texts listed landmarks, distances in days of travel, and descriptions of the shores. Young navigators spent years memorizing these sagas before being entrusted with steering a real ship. Human memory was the most reliable safe for storing vital information. The route description was as specific as possible and tied to visual imagery. The text stated that one must sail west from a certain rock for exactly 3 days until the ice appeared. Then one was to turn south and hold course until the saddle-shaped mountain disappeared over the horizon. Every detail was of critical importance and brooked no free interpretation by the narrator. A single mispronounced word could lead the fleet onto deadly reefs instead of a warm harbor. Therefore, teachers severely punished students for the slightest inaccuracies in reproducing the text. The unit of measurement for distance was a day's sail with a favorable tailwind. This was a highly arbitrary measure, dependent on a multitude of unpredictable external factors. However, for the sailors of that time, it was quite sufficient for rough planning. They knew that the journey to the nearest island would take 3 days, and to the distant mainland, 10. Based on this data, the supply of fresh water and dried provisions on board was calculated. The names of geographical features often served as direct instructions for action. Islands and capes were given names reflecting their appearance or hidden dangers. The name Dark Rocks warned of sharp rocks invisible in the twilight. Good Harbor promised deep water, clean, fresh water, and protection from the north wind. This toponymy was a universal language, understood by any navigator of the harsh seas. The word served as excellent warning signs in the absence of actual lighthouses. Before a long voyage, captains would hold lengthy councils with experienced sailors. They exchanged verbal charts, refining route details and sharing their latest observations. Some spoke of shifting sandbanks, others warned of new ice fields. This system of collective information exchange constantly updated mental databases. One person's experience became the property of the entire seafaring community. Stories of shipwrecks were also a vital part of navigational training. Analyzing others' mistakes helped avoid one's own fatal errors in the future. The sagas described in detail why a ship had crashed and which decision by the navigator had led to the tragedy. It was a harsh but incredibly effective method of learning from real-life examples. The fear of repeating the fate of their fallen comrades forced sailors to be extremely vigilant. The sea did not forgive carelessness and punished even the slightest display of overconfidence. The use of mnemonic rules allowed them to keep complex astronomical tables in their heads. Sailors memorized verses describing the movement of the stars by month. This eliminated the need to perform complex calculations in their heads on the cold deck. It was enough to recall the right line to understand which constellation should appear in the east. Poetry and mathematics merged, serving the practical goals of human survival. When a navigator grew old and his eyesight began to fail, he remained ashore as a teacher. His greatest wealth was not a hoard of gold, but his phenomenal memory. Young captains would come to him for advice before difficult and dangerous expeditions. Respect for the knowledge of the older generation was an absolute and unquestionable law. The oral archive remained relevant until the widespread use of paper and ink. The loss of the tradition of oral knowledge transmission occurred with the development of precise navigational instruments. When magnetic compasses and sextants appeared, the need to memorize verses disappeared. Paper maps replaced human memory, making navigation a more accessible science. But along with this, a unique, deep understanding of the ocean's nature was lost. Sailors began to trust needles and numbers more than their own eyes and experience. The oral navigation guides of antiquity remain an outstanding monument to human intellect. They prove that the brain is capable of processing and storing vast amounts of complex information. Words charted routes into the unknown, no less effectively than modern satellite systems. This invisible foundation allowed people to unite scattered continents into a single world. The legacy of nameless navigators is forever inscribed in the history of our planet's geographical discoveries. Today, we have immersed ourselves in the amazing world of ancient navigation, where intellect completely replaced technology. We have seen how incredible ingenuity made it possible to cross oceans without a single metal instrument. The experience of northern navigators shows that nature always offers clues to those who are willing to listen and observe closely. Please suggest topics in the comments for future videos that you'd like to see on our channel. And be sure to subscribe so you don't miss out on new, exciting historical investigations.